All right, let's get right into it. We tend to think of logic as this perfect, unshakable foundation for all of our reasoning. I mean, it's logic, right? But what if I told you that deep inside its classical form, there's a hidden flaw, a kind of self-destruct button that could bring the whole system crashing down? Today, we're going to explore that very flaw and the radical new way of thinking that actually fixes it.
Seriously, just think about this for a second. Imagine you've got this massive, complex system. It could be a database, a scientific theory, whatever. And one single tiny contradiction pops up. Now, what if that one little error didn't just cause a small glitch, but instead allowed you to prove that, I don't know, grass is purple, that 2 + 2 = 10, and that you're currently listening to this from the moon? Sounds completely absurd, I know, but that is exactly the kind of crisis we're talking about.
So to really get a handle on this problem, we've got to look at the system where it all started, classical logic. This is the logic that's the foundation for most of math and computer science, the logic we all kind of learned in school. But it turns out it has a very specific and, well, very fragile nature.
And right here, you can see the two big ideas clashing. On one side, you have classical logic. The slide calls it brittle and all or nothing, which is a perfect description. It just absolutely cannot handle a single contradiction. Then, on the other side, we have this evolutionary response, paraconsistent logic, a whole new system that's not designed to fear contradiction, but to actually manage it. So what is this so-called fatal flaw? What's the actual mechanism that makes classical logic so fragile? Well, it has this incredibly dramatic name that, honestly, it totally lives up to, the principle of explosion.
The fancy formal name is ex falso secutor quodlibet. Yeah, it's a mouthful. It's Latin for from falsehood, anything follows. And that sounds weird, but it's a real consequence of how classical logic is built. If your system contains a statement that is somehow both true and false at the same time, the rules of the game can be twisted to prove literally anything. And I mean anything. That the moon is made of green cheese, that 1 = 0, the whole shebang. Let's just walk through how this train wreck happens. So first, a contradiction shows up. Let's say your system believes both the cat is on the mat and the cat is not on the mat. The second that happens, bam, the principle of explosion is triggered. Suddenly, the same logical rules can be used to prove some totally random statement, like pigs can fly. And when you can prove anything, well, your logic is good for nothing. It's a complete and total collapse.
And the source material just nails it with this quote. A single contradiction doesn't just make the system a little weaker, it renders it entirely trivial and meaningless. The whole structure of reason just crumbles. So for classical logic, avoiding contradictions isn't just a good idea, it is an absolute do-or-die mission.
But what if we didn't have to be so terrified? What if there was a completely different way to approach this? And this is where the hero of our story comes in. A logic that's designed not to run away from contradiction, but to embrace it.
This right here, this is the turning point. Paraconsistent logics look at that principle of explosion, the very rule that causes the whole system to implode, and they just say, nope, not for us. They are built from the ground up with one goal in mind, rejecting that principle.
And this just reframes the entire problem, doesn't it? The goal is no longer this desperate all-or-nothing hunt to eliminate every single inconsistency from existence. Instead, the goal becomes way more practical, and frankly, a lot more realistic. To tame contradiction. To accept that it might show up, and to build a system that can actually handle it without freaking out.
Okay, so how on earth does that actually work? How can a system of logic just allow a contradiction to exist without immediately self-destructing? Well, the core idea is surprisingly clever.
So the main innovation, like we said, is just getting rid of that principle of explosion. And the result of that one little change is huge. In a paraconsistent system, if you have a contradiction, you know what it means? It just means you have a contradiction. That's it. It does not give you a golden ticket to prove that dogs can talk. This means the system can preserve meaningful, useful logic everywhere else.
The key concept here is something called containment. The best way to think about it is like a firewall on a computer network. When a contradiction appears, paraconsistent logic basically puts a little quarantine box around it. It contains the problem locally, which stops it from spreading and infecting the entire logical system. The falsehood is isolated, not allowed to explode.
And the upshot of all this is a real game changer. For the first time, we can actually build and work with what the source calls contradictory yet non-trivial theories. Now think about that for a second. These are systems that we know have flaws or inconsistencies inside them, but are still incredibly useful. Classical logic would just write them off as broken. Paraconsistent logic says, no, these are workable.
Now, I know this might all sound a little abstract, a little academic, but this is where it gets really, really important. This isn't just some philosopher's plaything. This is logic for our messy, complicated, and yeah, often contradictory world.
I mean, just look at these applications. Think about a massive company database with millions of entries from different people. Of course, there's going to be conflicting info. Or what about legal codes, where one law might accidentally contradict another? Even huge scientific breakthroughs, like the early models of the atom, were full of contradictions, but they were still vital stepping stones. In all of these real-world scenarios, classical logic would just throw its hands up and say the whole thing is useless. But paraconsistent logic lets us roll up our sleeves and actually work with the data, warts and all.
At the end of the day, that's what this is all about. Paraconsistent logic is a tool for navigating reality as it is, not as we wish it would be. It's designed for all those messy situations that classical logic would have to give up on. It accepts imperfection and just keeps moving forward, which, let's be honest, is something we all have to do every single day.
And that leaves us with this really fascinating question to chew on. For centuries, we saw contradiction as a complete dead end, a sign of total failure. But by changing just one fundamental rule, we've turned it into a manageable problem. So it really makes you wonder, if we can teach something as basic as logic to gracefully handle contradictions, what other problems out there that we think of as impossible are really just waiting for us to change our perspective?